Okay. All right. Well, yes. Happy Friday. Happy ninth week. This was, I guess, technically our last lecture because next week we have group presentations, final presentations. So no lecture on Monday or Wednesday. I'll just be meeting with different groups and. And basically, your final report is just due at the time of our meeting. So you could just email it to me like 1 minute before the meeting starts. So you've set your you've scheduled your appointment, and so just show up there, and you can email me the file like 1 minute before, and that's fine. Okay, no need to print anything out. It does need to be a PDF. I don't know, anything else. Yeah, that's that. And we'll meet. You guys will give me a little 5 minute presentation or so at the beginning. I'll spend the rest of our hour just kind of reading through your report, asking questions as I read through it, and that will be that. And then 1 week from today, on Friday, we'll have group presentations in the class. The groups, if you signed up to do a group presentation, there's a little bit of extra credit in there for you. So we'll have, I think, 9 groups presenting, and I think it'll be neat to just kind of see the projects that your classmates have done. Okay, and again, that presentation has to be exactly 5 minutes or less. I will cut students off at 5 minutes. Okay. All right. So this last lecture, I just thought I would just show like just a couple random additional visualizations that were like kind of neat, kind of fun. I don't know. You don't have to use any of these, but if something in here seems like, oh, that's kind of neat, that's something we could use, or we like this, we like the way it looks, sure, go ahead and include it in your project, or you look at this and you go, this is not for me. Okay, and whatever you guys decide, that's fine. Okay, but so here is a simple plot here. And so here, just for examples, I'm using the Diamonds data set, okay? And so remember, the Diamonds data set, there's 40,000, 50,000 rows, and there's different variables. One of them is a categorical variable, which is the quality of the cut. And a Diamonds cut can be rated anywhere from, a fair cut to good, very good, premium, and ideal, where ideal is kind of the highest rated, and actually most diamonds, when they get cut, they do a good job, and so they cut them into either ideal or premium, because actually cut turns out to be one of the most important things as far as like how the light reflects out of the diamond and stuff. And so the diamond industry is kind of like this weird thing, right? You just find these rocks, and but if you like cut them cleave them in a certain way, then light reflects and it's shiny and it's pretty, and that's what's going on. So anyway, we can take group by the cut and summarize, okay, and just say, hey, the total number of that cut is just so you can imagine the table here. Is going to be 5 rows with 1 column showing the total number. And then I can just do ggplot. Y here is the total. Fill is based on the cut, and do gm column. Okay. And then here I mapped x equal to 1 just so we have like a x value here, but that's what we have there. Okay. And then what you can do is you can do something to make it a pie chart, okay? And what we do here is we say make this a polar coordinate. So this is the exact same code here, okay? So this is a column plot, okay? and here I just said coordinate polar. Okay, and what that does is it just takes the y coordinate and makes it polar. And so rather than now going from 0 to the max, it's going to turn it into basically a 360 degree thing. Okay, and we get a polar coordinate here. And then theme void, so if you don't do theme void, it's going to include kind of like this extra information on terms of like coordinates, basically like your axes and things like that. And so what theme void is basically going to remove all of that extra information. And so this basically makes it a pie chart. Now personally, I don't really like pie charts, okay? But pie charts can be useful, especially. All right, so here's the thing. If you have more than 5 categories, definitely don't use a pie chart, okay? And pie charts, I would say, really are best if you have only maybe 2 or 3 categories. So if you wanted to do like kind of like a gender split, okay, then a pie chart makes sense, okay? And so you could have maybe 2 genders or maybe a third for non-binary or didn't disclose or something. I think that would make sense. But if you have something like, if you're looking at like all 50 states, a pie chart's just going to be absolutely miserable to look at. Okay, and so in general, no more than 6 colors, and for pie charts, I think 3 is probably your optimal number for slices in a pie chart. Okay, if you have a categorical variable with say more than 6 values or something like that, then probably your best option is to put the category along the x-axis, and you can have a whole bunch of different categories along there. But trying to use different colors to distinguish is going to make it tough. Okay. Here, I'm going to turn this into percentages. And so I've basically just done summarize total equals n, okay? And then I'm going to mutate them into percentages here. And so basically I'm just taking the sum of the total, okay? And then we're going to do, take this column total divided by the sum, and then I'm going to just round off to the nearest whole number. And you can do, round comma 1 to get, decimal values, but this is going to be kind of a, your percentage marker here, okay? So another option, instead of a pie chart, is something called a waffle plot, okay? And so to make a waffle plot, you have to, I'm extracting this column, okay? 3, 9, 22, 26, and 40. I extract it as a vector, okay? But when you extract the vector, it's just the numbers 3, 9, 22, 26, and 40. And we actually want the vector to come with names, okay? So this part here is just the creation of this table. And from the table, I'm basically pulling the column using the $ notation. I'm going to say from our summary table, basically pull that column for %. And that's going to give me a vector with just the values 3, 9, 22. And then what I want to do is I want to take the values in cut and use those as names for my vector. So we're going to give the name fair to the number 3, give the name good to the number 9, and so on. And so we get basically names for each of these numbers. And so this gives us a named vector. And so now if I print counts, we get the values along with their corresponding names. And this is what you have to do in order to create what's called a waffle plot, okay? And so what a waffle plot does is it takes the counts, okay, and it colors them out. So you might have to install a library called Waffle. Install that package as Waffle, and this is kind of like a alternative way to visualize this information. Okay, So this information, so we have fair and good and very good, premium and ideal here. The same information here is conveyed in the waffle plot. One nice thing about the waffle plot is it's in this kind of 10 by 10 grid, which makes it a little bit easier for people to read, right? So when you see this, you can say, okay, fair is the smallest, but I said, okay, what percentage does fair make up? There's no way to, it's really hard to judge, right? And what percentage is very good versus premium versus ideal? It's really hard to kind of judge because our eyes aren't really good at calculating angles, okay? But when we see this, we can say, oh, okay, there are, ideal is 40%, okay? And then you can look at this and then we get 26% for premium, and then, what is this? This is 22% for very good, okay? Just by kind of looking at this, and we can kind of yeah, indeed, those are the numbers being plotted. So the waffle plot, in my opinion, is superior for kind of conveying proportions of different things. And with a waffle plot, I think you can have more than 5 colors, more than you can have multiple of these things if you kind of want to do. One of I would say the limitation is that you're kind of limited to whole number percentages, which if you have things that are really small quantities, less than 1% or something like that, it's just not gonna work out. Okay, but if you have kind of just broad categories where they each kind of make up a few percentages, and you're not losing too much information by rounding off to the nearest whole percentage, I think a waffle plot's a pretty good way to show this. Okay, I think this is, in my opinion, fairly straightforward to understand. Very similar to a pie chart. Okay, we're probably accustomed to seeing pie charts, but in my opinion, without the numbers labeling these, it's really hard to kind of look at this green slice and this, I don't know, bluer slice, okay? Bluish aquamarine, I don't know, whatever color this is. And you really judge what's the difference here, okay? But I think here it's a lot easier to kind of tell. Okay, so just kind of moving on, looking at other categorical variables. Let me pause. All right, so let me also give you your first view quiz answer. Today's first view quiz answer is the letter E. E as in elephant. E as in elephant. Okay, so this so here is a plot we can use to show kind of the counts of 2 categorical variables. All right, so here I have one categorical variable for clarity. So I've kind of filtered our data to just these 4 clarity measures, slightly included 2, 1, and very slightly included 1 and 2, and so I have kind of these 4 categories for clarity, and then we have the 5 categories for cut. GeoMBar automatically tallies them up. If you don't tally them up, then you could create a summary table after filter. As after filter, you would do group by clarity and cut, and then summarize total equals n, and then you would map your total variable to the height. Okay, but here GeoMBar will count them up. Geom column basically just plots the values themselves, and this would be one way to kind of express that. This is if you don't do GeoMBar, here I'm saying, okay, after filtering it, we're going to group by clarity and cut, and we're going to do summarize total n. And so now I get the values: SI2 fair, SI2 good, SI2 very good, SI2 premium, SI2 ideal. Okay, and those are basically the same values that show up here. And so the difference here, okay, is GeoMBar takes into account those totals already. If you don't use GeoMBar, you can calculate the totals yourself, okay, by doing total is equal to n after grouping by both variables, clarity and cut. And then, and now we can use geom_column. And so for geom_column, you have a few options. The default, if you don't specify position equals fill, will be position, basically identity, and you would just get the same result here, okay? But by doing position fill, now everything gets matched up to 100%. And this allows you to kind of compare proportions a little bit more easily, okay? So, you know, when you look at this plot, it's hard to tell which clarity rating has the highest proportion of ideal cuts, right? So you can see, like, just because there's more, you know, as far as clarity rating S1, SI1, and VS2, there's more of them. And so, you know, your yellow proportion, you know, seems to grow, but it's hard to judge. However, by kind of normalizing everything so that everything has a total of 100%, we can see that the proportion of ideal cut, you know, the yellow shading has the highest proportion, right? And so this is, I would say, if you wanted to make the argument, okay, in your data as you're looking for relationships, you can say, okay, you know, ideal cut diamonds, you know, are basically higher rated and things like that. Ideal cut diamonds are the best, and you know, a lot of diamonds are ideal cut. But as the clarity rating goes higher, the proportion of ideal cut diamonds also goes higher, right? And that, I would say, that's not necessarily an intuitive measure, right? So if you said ideal cut diamonds cost more, you know, have a higher price, fetch a higher price, I would just say, okay, you know, that's kind of expected, okay? But if you say, as the clarity grading goes up, they also, like, the proportion of diamonds that get better, you know, have ideal cuts also grows, you know, that's like, oh, that's kind of interesting, right? And, you know, what's the reasoning behind that? You know, I don't know. We can suspect, you know, we can lay our kind of, you know, do speculation about this, and perhaps, you know, as basically VS1 is a higher clarity grading than SI2, all right? And so perhaps as they look at these rocks and they say, okay, this one is better than this rock, then it's worth, like, taking the time to make a better cut. I don't know, right? It's kind of just like, you know, if you have a good specimen, you want to kind of do a good job with it. And so, so anyway, this is kind of an interesting thing, right? And so this relationship where you see ideal cut diamonds make up a higher proportion of VS1 than SI2, you know, is not conveyed when you just look at the shear counts. Okay, so I'd say this is something to take into account, you know, when you make your graphics there. Okay. Oh, you know, we're gonna end up going through these slides. Okay. So here's another plot. So here's a histogram, and histograms are great to explore numeric variables. And so you can just kind of take your numeric variable here. We're looking at the price of the diamonds, and we do a histogram on the price of the diamonds, and we can see, okay, you know, we got, this is kind of what the price of the diamonds look like, and you have a geom histogram. Probably, you know, if you have a numeric variable, and just a hint here for your final project, if you have a numeric variable that you're looking at the very basic, include a histogram of it and just make some comments on the base distribution of this one numeric variable, okay? And then from there, do subgroups and comment on, like, you know, the different distributions. That's like an easy layup for just like, you know, if you're struggling with your analysis, just say, hey, here's a numeric variable that we're interested in. It makes sense to do a histogram. Okay, again, make sure it's numeric though, right? Don't get fooled by variables that have numbers but are actually codes or categories or something like that. Okay. Okay, so here is I've taken the histogram and I did a facet grid. Okay, so we've seen. So this is nothing revolutionary. This is nothing that's super surprising. And so here we just said, okay, let's look at the clarity rating. Okay, and look at the histogram here. And so IF is internally flawless. This is the highest possible clarity grading that you can get on a diamond, and it's there aren't a lot of diamonds like this. Okay, if you do have an internally flawless diamond, they're generally really small. Okay, because and then if you have a big diamond that's internally flawless, that's going to fetch a very high price. But the problem here is that we have such few counts that with the histogram, it's really hard to kind of see what's going on, right? So, I mean, this is okay, and you can say, all right, well, SI2 is probably the most common one, and I don't know, you got it's a little bit hard to say. There's also kind of this bimodal business going on. Okay, you have kind of a peak on the lower end for price. And then you have kind of this secondary peak that kind of grows over here. And then as the clarity rating goes up, then the price gets higher. So these all might be, my guess would be something like a 1 carat diamond. That's a very popular size. And so a 1 carat diamond that's SI2 is going to fetch around this price. A 1 carat diamond with a higher clarity grading, a 1 carat diamond with a higher clarity grading is going to fetch even higher. And if you get a 1 carat diamond that has a VVS2, which is a very high clarity rating, it's going to fetch an even higher price. So that's my guess as far as what's going on. You'd probably have to do a further analysis to kind of judge that. But anyway, this is one thing that we can kind of see with a histogram. But there's some shortcomings of it. And so one thing that might serve us a little bit better than a histogram, okay, is to use is geom density, okay? This time I did a density plot based on the cut, okay? And so density, rather than having just kind of the bars of the histogram, density will kind of create a smooth curve. I can also do a density for this previous plot, and it's going to look very similar. It's going to look very similar, but this, gives you a little bit of kind of, I guess, smoothness. One other thing that the density does is that it normalizes all of the area to be the same size. So here, the histogram just plots the counts directly. Okay, and so here where there's very few internally flawless, we don't, it's just very, very low. It's hard to see because the plots are, the counts themselves are very small. But let me go ahead and copy this and replace geom histogram with geom density here, and you can kind of see some of the difference here. All right, so that's geom histogram. And let me just change this to geom density. Maybe I will do fill equals. Specify variables on clarity. Okay, I'm just having trouble with. Oh, okay. So here is a plot of kind of the density, or the histogram versus the density here. And so one thing, so it's I don't know if this is an improvement. It's really hard to see. Probably we will be our plots will be improved if we just filter just to a few of these things. So probably in both cases, it would help to filter if we did clarity percent in percent, and we do SI2, SI1, VS2, VS1. So here is, so here's your histogram and the corresponding kind of density plot. And so these, just kind of smooth out the plots. As far as, which one does a better job conveying information, it's hard to say. Probably if we even, filter down to things less than 10,000, right, to kind of get a closer look. Because what we're seeing is in all of these things have this long tail of some really expensive diamonds or something, and so we can kind of look at, say, if you're shopping for a diamond and you say, okay, my budget is I don't want to spend more than $10,000 on it. I mean, I don't know, $10,000 on a diamond is a lot of money, right? But you can kind of get a sense of like, all right, what kind of values are there? What kind of things do we have? Okay, so here's just a density plot, and then I colored the fill based on the cut here. And then there's kind of just for fun, there's a few things. So here is, you can create a box plot, right? So this is all kind of looking at similar stuff. And if I do, so rather than density, I can do geom box plot. So sometimes a box plot, you have to do here to kind of, we're going to do Y on clarity to separate the different groupings here, right? So this is all the same. Okay, so here they're in opposite directions, okay? But so one thing to note is clarity, SI2 shows up at the bottom over here, and it shows up at the top over here, okay? Same information, just presented as a box plot. And sometimes the box plot is actually easier to digest than the density plot or the histogram, okay? Looking at just kind of one of these variables. And you can just, because with the box plot, you can kind of just look at this thick line down the middle regarding median price, and so you can see, interestingly enough, as the clarity grading goes up, the median price seems to drop, okay? Now, probably what we would also want to do is do a plot of like what your median kind of size of the diamond, median, what other kind of factors are being included here, okay? So there's you can do a box plot like that, okay? Here again, going back to the histogram, this is okay, or there's our histogram, okay. So here I just wrote, the previous slide doesn't seem to reflect what our knowledge would expect. We would expect price to go up as clarity improves, and what we're seeing is kind of the opposite. As clarity goes up, internally flawless, which is the highest clarity, the median price seems to be going down, right? So what's going on? probably, size is playing a different role, okay? And so, maybe with these lower clarity diamonds, we have higher size, okay? And then for higher clarity, we have smaller size. So one thing we have to do is we kind of have to restrict our diamonds to a given size. So this is kind of like a little bit of like Simpson's paradox. And you saw a little bit of this like in the exam when you were looking at the penguins and things like that. Sometimes the overall trend, kind of seems counterintuitive. And that could happen if you don't take into account, other variables going on, okay? So what we're seeing is that like a higher grade and clarity is actually associated with like lower median prices. But what's going on is that higher clarity diamonds just are generally smaller. So here I said, let's filter our diamonds to just those where the size of the diamond is right around 1 carat. So you often have diamonds that are just a little bit under 1 carat, a little over 1 carat or something like that. And so now we get the relationship that we're very much expecting, that for 1 carat diamonds, as the clarity grading goes up, you can see the median price definitely goes up as well, okay? That if, it's also gonna be very clear here. So here I'm gonna just say filter where carat is less than 1.05 or and carat is greater than 0.95. Okay, and we see, yes, as the clarity grading goes up from SI2 to SI1 to VS2 to VS1, VS1 being a higher clarity grading, we can see the median price goes up. And so it's just kind of interesting, this kind of relationship, the relationship between price and clarity, when you take into account all the diamonds, actually is in reverse. But if you limit yourself to diamonds of a certain size, then you have this, relationship that we are expecting, right? And so, these are, I think, interesting findings that, especially something like this seems a little counter, and, how do you explain that away? We have that, okay? Okay, I'll go ahead and just give you your last 2 view quiz answers. Second one is C as in cat. And the third one is B as in bear. So C as in cat and B as in bear are the last 2 view quiz answers. Okay, here, instead of a box plot, you can do something called density ridges, which is just kind of like a little fun little diagram. It's kind of like a density plot, but they allow for a little bit of overlap between them. In order to do this, you have to call in a library called ggridges, but I don't know, this makes kind of just fun little plots. So you have these, you have these box plots which illustrate things, but you can also kind of do density ridges, which basically create density plots, but allow them a little bit of like overlap to kind of give this, I don't know, sense of depth and scale, and just, in my opinion, makes it a little bit, a little bit prettier, okay? And then, if you include some kind of color palette that shades the things accordingly, and you include like a little bit of transparency, you get some nice looking graphics and stuff, okay? Again, completely optional. The underlying content is more important than the aesthetic pleasantness, okay? But if you are at a point where you like the graphic that you have and you're just saying, okay, can we make this even a little bit prettier or something, something you can take into consideration. Okay, this one, I don't know if it's all that pleasant or something, okay? Here, I'm doing a jitter plot, okay? And we're looking at price. We're looking at all kind of diamonds that are around 1 carat. And we can see, there's a whole bunch of diamonds that are 1 carat, in this grade. And so we're looking at clarity rating, we're looking at price, and then also within each of these things, we're looking at the cut rating, okay? And what we see in general, okay, so the palette here is fair gets red color, ideal gets blue color, and things in the middle get, yellow, go red, orange, yellow, green, blue, right? So kind of a little bit of rainbow color. And this kind of aligns with what we see is that, okay, red for fair cut gets kind of the lowest, and ideal cut gets the highest kind of price within each of these things, right? And of course, there's some spread because there's other factors at play. And but just in general, especially for SI2 and SI1, we see red towards the bottom, blues towards the top. Okay, and interestingly enough, as the clarity rating gets higher, you get more and more kind of spread in each of these things because now the diamonds are like really expensive. For 1 carat diamond, this is over $10,000 and things like that. So. And this data set's fairly old. I don't know how much diamonds cost today, but probably with inflation even higher and things like that, right? So, so this is what we have there. So that's one possible plot. And here's just kind of another one. Here I'm just limiting ourselves to just three cut ratings and 3 clarity ratings. Okay, just to kind of simplify things a little bit. And so you can see how much how much spread we have. And so you can see overall, fair cut gets the lowest, ideal cut gets kind of the highest, right? So greens generally towards the top, red, oranges towards the bottom for each of these things. Different spread as the clarity goes up. For diamonds of 1 carat size, the average goes up and things like that, right? So these are just different kind of options to consider. You can kind of decide what is aesthetically pleasing, what communicates the idea that you are finding and you want to see in your graphics. So again, just things that you may or may not want to do as far as your final project goes. Again, there's lots of options, I imagine, with your data, and I have office hours today. Also tomorrow. Oh, actually, I don't know if I'll have to see. But yeah, come on by. I'm happy to help. Good luck as you wrap up your final reports. I look forward to our group meetings next week, and yeah, thank you for a great quarter. We'll see you guys, I guess, in 1 week on Friday for our group presentations. I'm looking forward to that. Okay, all right, thank you guys, and yeah, have a great rest of your day. Have a great weekend.